and they are elastic in nature, which is associated with the motion one. Okay, so this manometer and all these means they are used. So we will see one by one point of pressure measurement, and we will start with the classification. First point is the static one, under which manometer criteria falls. And these manometers are further classified into different categories. So that also we people are thoroughly going to visualize and see. So first of all, what is a manometer? And where we people are using these manometers are actually commonly used device in our day-to-day life also. When you people are performing the practical, at that moment, while performing the practical on the process loop, there is one scale which is mounted on the tank. That is also one type of liquid level measuring mean. But however, if I want to measure the exerted pressure of the two different points, there are some means. They are feasibly or commonly used two glass tubes. They are represented in U shape, or either you can use a flexible one, or either you can use one fixed molded type also. I will show that particular aspect also to you people in the upcoming slide. So manometer is nothing but it is the simplest device that is used for the measurement of a static pressure. Then with what type of liquid we people are using in that one? There are different types of liquid that can be used for the measurement of this static pressure. So under that category, you can use a water, you can use a mercury, or other mean for the measurement that is in the form of liquid. Water is the commonly used one, or the mercury is the commonly used liquid for the measurement of the pressure. Why this is so? Water is the clear liquid. No doubt, the clear liquid may create the observation error, but you can even introduce some color in that water, and you can observe the variation in the level. No doubt that mercury, many of you people may have seen the color of mercury. It is somewhat silver in color and having the higher weight also. So that silver color is reflected or transmitted through your reflection from the glass tube, because we are using the transparent glass tube for the measurement of the pressure in particularly in manometer, so as to note the readings. And between the two legs we are having the scale. uh, that scale is associated with the leg whose height we people are interested to measure. So when a pressure line is connected to one of the leg or one of the column of the manometer, there will be variation in the fluid of that particular leg or the column. So column and leg of the manometer are same. I will show that one also. So force is going to be exerted and there will be variation in the leg. Okay, so over here actually the unknown pressure will be applied on the pressure on the one of the leg, and that unknown pressure, depending upon its force, there will be variation in the output. So by measuring the difference between the height of two columns, uh, two columns or two legs, we are measuring the pressure at the inlet that can be expressed in terms of inches of fluid. So pressure measurement based upon the difference or balancing the weight of fluid column between the two pressure of the inserted legs, or a large pressure difference that is measured with a heavy fluids. So where we people are using water or where we people are using mercury, so this has been justified in this particular statement. So when there is a large pressure we people are applying, So that large pressure difference we people are trying to measure with the mercury one, because mercury is having the higher weight. Okay, so mercury is having 760 mm of Hg pressure, equal to 1 atmospheric pressure. For the smaller pressure difference, like as we people are conducting the experiments normally, or tube level which we people are determining in the construction line also, those experience in the experimental of the wind tunnel are measured by a lighter fluid such as a water, and water is having the pressure of 27.7 inches H2O. So that is your H2O, not H2O. Okay, H base to 2, H base to 2O. So this is the symbol for your water. Okay, which is equal to 1 psi, and 1 centimeter H2O is equal to 98.1 Pascal. Okay, so these are the continents that are provided. So we will see one by one type of manometer. So there are three different types of manometer. One is your YouTube manometer, and this particular part is the YouTube manometer. Second one is the well type. Well means in Marathi we people are saying Vihir. So it is similar to that of your well, and only one leg reading we people are considering in this particular aspect. And another one is the inclined type, means the resultant is represented in the inclined manner, and we are having the structure L type, well type, not L type, but well type of the structure is present over here. Now, how we people are measuring? If you observe in all the cases, what I want to represent in this from this particular figure, these are the three different types, and we people are going to visualize individual one in the depth. So, in YouTube type of manometer, when pressure is not applied, when pressure is not applied, if you observe, it is lying at the zero level. Now we have applied a pressure in the second mean, we have applied a pressure over here. At that time, whatever the pressure which has been applied, due to which the force has been exerted on the fluid, it has been moved to the downward side compared to this one. But at the same time, here your height has been increased. Height of the liquid has been increased depending upon the pressure. At the another end, if I have applied a vacuum, means it will suck that particular liquid. Again, there will be variation in the liquid level, and that height will be measured. So we people are having the density of liquid, gravity of that particular liquid, and we have determined the height. So we can easily determine what is the pressure that has been pressure change that has been occurred in utilizing this manometer. Second one is our well type. Now well type, in this one, very light change in the liquid column will take place, because what happens, which liquid column? The well type liquid column. So whatever the force at the initial condition, force is 0, P is equal to 0, you are having the same level. At this one you have applied, though the pressure applied is the larger one, the movement at this particular point is the minimum one for the liquid, but the maximum in the smaller leg, in the smaller leg. So this difference we people are trying to determine, and similar is the case with the inclined type of pressure measurement at zero level. Actually here we people are not getting any variation, but however when vacuum, or when we are having P is equal to 0, though the level is same, but after applying a pressure at the smaller end, the fluid will move in the downward direction, and it will try to fill this well in the inclined type. Here we have to consider the angle theta also while measuring that particular pressure. So these are the three different devices. They are commonly used for the pressure measurement in static pressure measure. So first one is the manometer. Now here we people are going to consider one of the example. We are having the I have seen that when my pressure is 0, at that time level is going to remain same. So with the black line, level is same. With the red line that I am going to represent, pressure P2 is applied to leg 2 and pressure P1 may be applied to your leg 1. So this pressure P2 is greater than that pressure 1. Definitely force will be exerted on the liquid. So it has been moved to the downward side, and based on that one, there is a movement, means this one is the change in the height which I have got. So here it has been represented as a H. As per as the definition which we have considered, that P is equal to rho GH. As per as the definition which we people have considered, P is equal to rho GH. But here we people are having we are not having a single pressure. We are having two pressure. That two pressure is P1 and P2, in which my P2 is greater than my P1. P2 is greater than that of my P1. So here, if I want to specify this particular, rearrange this particular equation, how I am going to correlate this equation? So I want to determine the height. So height can be given as P divided by rho G. But I am not applying a single pressure. It means I am having two pressures, P1 and P2. So my P1 minus P2, P1 minus P2 divided by rho G is nothing but my height. Is nothing but my height. So that is the variation I am getting. So here, if I want to determine the pressure, so I can rearrange my entire equations, as I have in the first slide in the introduction also I have provided you the information regarding that particular concept. So what was the concept that has been specified? That when I am not having a single P, I can represent that one as a delta P, and which can be given as P1 minus P2, which can be given as P1 minus P2. So delta P, instead of P, I can represent delta P, but instead of P, I can represent as a delta P. However, this delta P is equal to P1 minus P2. So I can replace that P1 minus P2 is equal to rho GH, rho GH, where my rho is the mass density of the fluid, G is the gravity, acceleration due to gravity, P1 is the unknown pressure which I am interested to measure, and P2 is my atmospheric pressure. But here my atmospheric pressure is greater than that of the unknown pressure. If my unknown pressure is greater, then definitely P1 minus P2 will be in the form of positive resultant output. But when my atmospheric pressure is greater, at that time I am getting the resultant output in terms of minus. So this is the basic fundamentals of U-tube manometer. So water, mercuries are used as a manometric fluid commonly, and even you can introduce some color also so as to identify, because the glass tube and the water color is the similar one, so that may impact over it. So advantage of using this fluid is that